Based off of the blower door test from your energy audit, we're going to come up with a threshold number. Your house has got this much air leakage. For a proper amount of fresh indoor air, you need about 8 or so air changes per day. That's the entire volume of your inside of the inside of your house exchanging with the outside each and every day. If your house is over that amount, your house is too leaky. So you can go ahead with weatherization, air sealing attic spaces, add insulation to your heart's content, and you won't fall below this level. If your house is in this gray zone, or if you're below it, that might mean you need to provide additional fresh indoor air to the home each day. The reason why we need fresh air is a couple of items. First, you don't want your unconditioned air coming in from undesirable locations. So if you're relying for fresh air inside your house to come from an attic space or a basement banner rim joist, it's coming in an unfiltered and uncontrolled amount. Secondly is that moisture becomes a bigger concern in houses that are too tight. And so you want to make sure that you remove the stale air or excessively moist air from the source of where it's being created. In this case, we're in a home downstairs in Chantilly where we are in the gray area on fresh indoor air quality. So what we're going to be doing is installing an ERV, which is an energy or an enthalpy recovery ventilator. What the ERV does is that it balances the exhaust flow outside the house and it brings in the same amount of air from outside the house for fresh indoor air. The ERV recovers about 80% of the heat of the outgoing air supply and puts it into the incoming air supply. So it's an efficient way of making sure that your house is breathing or bringing in a consistent and a filtered amount of indoor air. So come with me, let's check out the inside of the ERV unit and we'll show you how to install one of these. How high did you want to go on the spring, the bottom of the spring piece?
No, because they're all different.
So here's the inside of our ERV unit. We've got the casing here opened up so that we can look at its inner workings. And basically what happens inside of an ERV is that you're pulling stale or exhaust air outside of the home. It's moving through one channel of this, in the top, down through the heat exchanger, out through an exhaust supply. You're bringing in some outside, or what we would call fresh air, which is coming from outside the house, coming down the other side of the heat exchanger, and then moving in a supply duct that goes back into the HVAC system. The net effect of the ERV is that you've got a balance with two equal-sized fans, top and bottom here, of airflow for both pulling air out of the house and bringing fresh air in. Now the main portion of the ERV is what we call here a heat exchanger. This is a couple hundred little metal fins that allow the air to transfer through conductive forces, heat specifically, and then some moisture. There's no actual exchange, there's no mixture of the two air supplies. So the stale air that's coming out of the house has no interaction physically with the air that's coming into the home. But these metal fins in the heat exchanger allow the heat from the outgoing supply to transfer about 80% of its energy to the incoming supply air. What that means is that even in the middle of the winter time, you can be running the ERV and it's not going to dramatically impact your interior air temperature because you're recapturing the majority of the energy from it.